In this video, we're going to talk about scientific notation. And to do that, I want to start with a really simple problem. I just want to start with some random number. We'll start with 3.2. And I want to multiply that by 10. The question is, what happens when you multiply that number by 10? And many of you know that 3.2 times 10 is just going to be 32. All right, what about 3.2 times 10, but times another 10? Well, that's just going to be 320. How about 3.2 times 10 times 10 times 10? Well, that's just going to be 3,200. And if you haven't seen this pattern before, you're probably understanding it now. Every time we multiply by a factor of 10, essentially what we're doing is we're adding a 0, or you can think of it as taking a decimal place and moving it to the right, and filling in all those numbers with zeros. So let's just do one more. If we multiply by one more factor of 10, we get 32,000. Okay, what's going to be important here is what happens in the middle. I'm going to rewrite this line on the left, 3.2 times 10, and 10 can be thought of as to the first power. The fact that we did this is going to make a little bit more sense when we write down what the second line is. We're going to copy down the 3.2, and we're multiplying that by 10 times 10. Well, we can think of that as 10 squared, or 10 to the second power. Okay, I'm going to copy down the 3.2 again on the third line. 10 times 10 times 10 can be thought of as 10 cubed. And finally, 3.2 times 4 tens can be thought of as 3.2 times 10 to the fourth power. So basically all I've given you so far is 3 different ways to write the same number. Well, sometimes in science we have numbers that are really, really, really big. So I guess my question to you is, what if we wanted to write the number 32 with 9 zeros on it? And let's say that's a number that pops up in all kinds of calculations you're doing in whatever science field you're in. Well, do you really want to write that number over and over and over again? Especially, what if it had 20 zeros? What you'd like to be able to do is to condense this into a number that, I guess, has less symbols in it. Something that's easier to write. So maybe we could write it like this. 3.2 times 10 to what power? We multiplied 3.2 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factors of 10. So my argument, and a lot of scientists' argument, is that this number is a lot more difficult and cumbersome to write than this number right here. So when you're dealing with really, really big numbers, this number right here is preferred. And we call this way of writing numbers scientific notation. Let's do a quick problem. What if we had this giant number here? How could we write that number in scientific notation? Well, the way to always write a number in scientific notation is to have one whole number and a decimal after that first whole number. And then after that decimal, you're going to write all of the numbers that aren't 0. Or in some cases, you might round. But in this case, you only have one other number that isn't 0, so we'll write that number right there. Then you write it times 10, and the question is to what power? Well, to find the power, you just kind of have to count the zeros. Our 5.8 decimal place would be here. We multiplied it by 10. 4, 5, 6, 7, 8, 9, 10 times. So this giant number, which I believe is 58 billion, can be written as 5.8 times 10 to the 10th power. Let's do one more quick example. Let's write this number in scientific notation. So what you do is you write down the first whole number, follow it by all the numbers that aren't zeros, and the question is, how many factors of 10 did we multiply this 1.2345 by? And in this case, you just have to count. 1, 2, 3, 4, 5, 6, 7. There it is right there. Now, if you don't want to carry all of these numbers along, if you don't need to carry all of these numbers along in the problem, the 2, 3, 4, and 5, it's possible to round. Where you want to round is just going to be based on the problem that you're asked to do. Okay, let's move on and let's talk about really small numbers now. Let's again start with the number 3.2, just a random number. Instead of multiplying it by 10, I want to divide it by 10, or you can say multiply by 1/10. If you divide something by 10, basically all you do is you move the decimal place in the other direction. What is 3.2 times 1/10 times 1/10? Well, that's just going to move the decimal place twice to the left, and we can continue this pattern. 3.2 times 1/10 3 different times. It's just going to give us that number right there, and I'll do one more, and I think you see the pattern at this point. Now again, the important part is going to be what we write right here in the middle. Again, I'm going to copy down the 3.2. In this 1/10, well, the 10 has this little power of 1 on it, and you learned in a previous class, if you have a number with a power on it in the denominator, you can move that number up to the numerator, but you have to make the power negative. So in other words, 3.2 times 1/10 can be written as 3.2 times 10 to the negative first power. Okay, let's look at the next line over. Let's copy the 3.2. 1/10 times 1/10 can be thought of as 1 over 10 squared. Using the same rule, I'm going to copy down the 3.2. Since the 10 squared is in the denominator, we can move that term up to the numerator and make the power negative. So 3.2 times 1 over 10 squared can be written as 3.2 times 10 to the negative 2 power. We can continue this pattern. The next line is going to be 3.2 times 10 cubed, because you have 10 multiplying by itself 3 times in the denominator down here. Again, copy down the 3.2. 1 over 10 cubed can be written as 10 to the negative third power. And the last line, if you just follow the patterns, can be written as 3.2 times 10 to the negative fourth power. Okay, here's why we're doing this. In science, you also have numbers that can be very, very, very small. Say you have a number like this crazy looking thing in one of your calculations. You don't want to have to write that number over and over and over again. So what you want to do is use scientific notation. You want to write it as 3.2 times 10 to some power. What is that power? Well, you just have to count the decimal places. Let's see, 3.2 would be here, and you're counting 1, 2, 3, 4, 5, 6, 7 decimal places to the left. So we must have multiplied 3.2 by 10 to the negative 7th power. Again, this is also scientific notation. Scientific notation is really good at writing numbers that are very, very, very small. That's a lot of zeros after the decimal place. Or very, very, very big numbers. Okay, that's your brief introduction to scientific notation. See if you can do a couple of problems. Rewrite this really big number using scientific notation, and also rewrite this really small number using scientific notation. Just follow the patterns that we established above, and hopefully you can figure it out. Alright, I'll see you in the next video.